I would call that x equals 1. Right? Don't need a fancy formula. It's just x equals 1. Oh, no. Hold on. Okay. What else do I know? Amanda, what else do I know? How did you find the vertex? Hold on. How did you find the vertex? Okay, you got to be more specific. How did you find the vertex? Michael? Perfect, substituting. Guys, as soon as you told me what the axis of symmetry is, doesn't the vertex lie somewhere on the axis of symmetry? Well, I've got news for you. By just looking, oh, I got to change my color again. By just looking, I also know that I've got another point right here because of symmetry, right? So I know, and I'm pretty darn sure where it's going to be now just by looking at it, but I know that somewhere on the axis of symmetry is my vertex. Do you think it's here? Do you think it's here? Do you think it's here? I think it's got to be down here, right? Okay. All right. This is -9, guys. Okay, so it's right here. I can see where it's happening, but let's just, when you know what your axis of symmetry is, you're halfway there. You already know what x is. You just have to find the y. So in order to do that, I could use this formula or this equation, or I could use this one. Whichever one you want. Which one is easier? Which one do you think? This one? That one? I'm going to use this one, just because. So, if f of x is equal to x, which I know is 1, plus 2, times 1 minus 3, isn't that just 3 times, I did something wrong. I was answering my own question as I was doing it. Should be a 4. Why is there so much talking behind me? 3 times -3, which is -9. I just found the other part of the mystery, but I already knew it just by looking at it. Okay, so there's my beautiful graph. I knew all of that. Didn't you guys know a lot? Okay. Yes, question.
Yeah, that's what I thought.
Okay, so there's a whole bunch of side chatter when that was a really good question. She said, I thought you can't use x equals -2 because that's a whole line. Technically, you're right, but when I'm answering this question, I'm solving for x. So I could technically write, what are my zeros? Well, my 0 is at where x equals -2, right? So if I'm talking about it in context like that, you're right. If there wasn't any words right here and I just wrote x equals -2, you're absolutely right. That is just a line. Okay. Good question. Really good question. So she's saying technically if I was to write my zeros, I should write them as an ordered pair because it's the graph. And she is right. But when I'm using it in context of what my 0 is, didn't I do that by solving for x here and solving for x here? Okay. Good question. Love it. All right. So I'm going to go forward now. I think we're good. I don't think I need another one, right? This one is just one that is, I just have to factor it. Can anybody just look at it without doing any work? No pens. Tina, put your pencil down. And could you tell me what's different about this graph? Hold on. Let everybody think for just a quick second. I'm going to call on somebody. Okay, I'm going to give Sreya an opportunity. Sreya, can you tell me what's different about this graph? A repeating zero. A double root. Why is there a double root? No, just a double root. Because this, in factored form, is really what? X plus 2 squared. So we have a double root at -2. I also know that I've got 4 is my y-intercept, 1, 2, 3, 4. Since this is a double root, it's also the axis of symmetry, right? And then I also know that there's symmetry here. Oops, that was still a line. So really, that's all I needed, right? Hey, check this out. Over 2 up 4. Over 2 up 4. Right? Have we been talking about those magic numbers? What's the other magic number? 1, 1. Huh? See that, Philip? I know. Connection. It's all over the place. Okay. All right, so I have a challenge for you. Okay, here's my challenge. I need everybody's attention, please. So here's my challenge. So this is what we did in the very beginning, right? If I have y equals 4x minus 8, that's a line, right, with a slope of 4 over 1. And then this one's really easy to get y by itself. If I want to find the inverse of it, I just switch x and y, correct? And then I would just add 8 to both sides, so now I've got x plus 8 equals 4y. And then if I divide everybody by 4, that's what happened here. So on this step, we switched x and y. To get to this step, we added 8 to both sides. This step, we divided everybody by 4. And I'm left with y equals 1/4 x plus 2. Okay? So that's the inverse. Today, it's a little bit harder. If I have y equals x squared plus 6x plus 8, and I switch x and y, I've got 2 y's now. How am I going to solve for y when I've got 2 y's? So I'm going to take this off, and I'm going to take this off. You know, actually, I'm just going to duplicate the slide when I do that. Duplicate the side, take this off. And I want you guys to think about this for a second. Can you find a way to solve for y? The idea of solving for y would be you only have one y and everything else is on the other side. So you guys try it. Try together as a table group. I'm going to walk around and see what you guys come up with.